Good morning, chemists. So today we're going to be going over the spectrophotometric analysis of phosphate in lake water. Quick overview of this little pre-lab lecture. We'll be going over some of the theory. We'll go over the procedure, the lab report, and then you can clean up, check out, and I'll see you next week. So kicking it off with some theory. Phosphates are essential nutrients and they're present in many natural sources. They stimulate growth of plankton and aquatic plants that provide food for fish. In moderation, phosphates benefit the environment, but in excess, phosphates can cause overgrowth. This overgrowth leads to oxygen depletion, and there's more harmful consequences for the aquatic life. So we need a balance. We also need a way to quantify phosphate concentration so that we can monitor it, control it, and keep the environment in tip-top shape. So one of the ways that we're able to observe our phosphate concentration is through spectrophotometry. Spectrophotometry relies heavily on Beer-Lambert law, which I have displayed right there. A is equal to epsilon BC, where A is the absorbance. It's equal to molar absorptivity times path length times concentration. The big picture idea that you should take with you after this lab is that absorbance is proportional to concentration. You'll go more in depth with this in your lecture, but you may be asking to yourself, how are we going to observe this? Well, we'll prepare a calibration curve, and that plot will allow us to visualize and mathematically understand how absorbance is proportional to concentration. So by the end of this lab, you'll have a really nice calibration curve, you'll have absorbance plotted to concentration, and you'll have a really cool linear relationship. The more phosphate you add, the higher the absorbance. So if you're doing this lab and you see that you have a negative slope, you hit a hurdle somewhere and you have to go back and fix that. Moving on, procedure-wise, what we'll be doing today to prepare the calibration curve is making a series of standard solutions from a phosphate stock. So in the back of the lab, there's going to be a bottle of 0.01 molar phosphate stock, and you'll be measuring out certain quantities of that stock solution to make your standards. You'll measure out 0 mLs, 0.5 mLs, 1 ml, and then 2 mLs of this phosphate stock. You'll add some color reagent, and then you'll dilute it using deionized water to the 100 ml mark of your volumetric flasks. Once you have these standards prepared, you can measure the absorbances of these standard solutions using the microlab spectrophotometer in your lab bench. So you'll have a series of absorbances. You'll have some concentration values. You can plot them on Excel to create an XY scatter plot. That will give you your calibration curve. That will then lead you to the final step of this experiment, which is the unknown trial. There's some pond water up front that you can create one last sample. You'll take that absorbance, and then using the calibration curve, you can determine the concentration of phosphate in that unknown sample. So that is the extent of the procedure for today. Let's move on to the lab report because I have a couple notes there. For the final concentration, this all is a dilution calculation. So we will be using M1V1 is equal to M2V2. The M1 is that initial phosphate stock that you got from the bottles in the back. And then our V1 will be however much you measured. So the 0, the 0.5, 1, 2 ml, etc. And then the V2 will be a 100 ml volume because that is the total volume of the volumetric flask that you diluted to. So that's how you should get those values. The absorbances are given from the spectrophotometer. And then lastly, for that concentration calculation, you are able to use Beer-Lambert law and that equation to figure out your concentration, or you're able to use the equation that was given to you from your calibration curve. Either way you choose to do it, just show all your steps and you should be good. So that was my pre-lab lecture. You have all the information that you need to get started. So have fun and get to work.